All right, so I couldn't figure out how to get the tablet to work on my computer, so for this one I'm just using my iPad. So I do find it a little bit harder for me to write with the iPad than with my tablet, so we're just going to go through both methods now, and you can choose which one that you feel most comfortable with. So we're going to use the fraction method first, or for this one. So if we're approximating the square root of 105, first thing, no matter what method you're doing, you're going to your reference sheet and seeing, okay, which perfect square do I have that is greater than and directly less than our 105? So 105 falls in between this 100 and 121. So I'm going to write the square root of 100 because that's less than, so to the left, and the square root of 121. I know that the square root of 100 is 10, and I know that the square root of 121 is 11. If you're not sure, just on memorization, we can look at our reference sheet and see, well, if this is x squared, then we know that x is the square root of x squared is x, so this gives me what its square root is. So we know it's 10 and 11. So that means I know that my answer is going to be 10 point something because it's falling in between the perfect squares of 10 and 11. So using the fraction method, and that's if you guys are good with approximating fractions and fractions don't scare you and fractions you're good with, then this is the method for you. It's not only faster, but if you're good with looking at a fraction and being able to say, okay, that's a third of it approximately or a quarter of it, then you'll be able to really quickly guess and approximate what this value is. So once we do this, we then take our number that we're trying to find and we subtract the perfect square that's less than it. So 105 minus 100 is 5. And then we take the other one, 121, and we're going to subtract 105 from that, which is then going to give me 16. And when we do this, it's now going to give me my fraction that's going to help me come up with our approximation. So it's 5 over 16. As we talked about in class, it's always going to be less than 1. So even if you're unsure of which one goes where, the smaller over will always be over the bigger because it's a percentage of the number that we're looking at. So now I look at this and say, okay, I'm going to approximate 5 over 16. Well, 5 over 16 is awfully close to 5 over 15, which I know is equal to 0.33. We can also, so then it's awfully close to 0.33. And then now we look and say, okay, which number was greater? Was 5 over 16 greater than 5 over 15, or is 5 over 15 greater than? Well, when we're looking at this, this is saying how many we have of the whole number 16. So in this case, we have 5 pieces or 5 parts in both. And since the whole number here that we're looking at that would be the full grouping is smaller, that means that this 5 is a higher percentage of that grouping. So that means 5 over 15 has to be greater than 5 over 16. And the reason why we're doing that is I know now that this number, 5/16, is less than 0.33. So when I'm making my guess, like I said, as our denominator gets bigger and bigger, it's a smaller percentage as we're moving. So maybe I do just guess 0.3. Maybe I guess 10.2. I would probably just say 10.3 for this one for myself, just based on this here. And now let's go ahead and look and see, well, what is the exact square root? So the square root of 105 is 10.247. So you see it's between 10.2 and 10.3. So my approximation here is still accurate. All right, maybe 10.2 would have been a closer and better prediction, but that is still going to be acceptable as an answer. For this one, once we get down to it, 10.2 through 10.3 would have been an acceptable range as an answer. Anything beyond that, once we start doing these more and more and get the hang of it, would be approaching instead of proficient. All right, so that's using the fraction method.